Hi everyone, welcome. In this class, we will discuss some questions, organic chemistry questions, and let's see how to solve the questions. The very first question is arrange the following compounds in the increasing order of their densities. So we need to compare the densities. Okay, we have these four different compounds. The first one is that's your benzene, right? And this is your chlorobenzene. Okay, and this is 1,3-dichlorobenzene, 1,3-dichlorobenzene, right? And this is your 1-bromo 3-chloro, 1-bromo 3-chlorobenzene. Okay, so in these three different compounds, we just need to compare their densities. Okay, so what is the concept of densities? If you have the idea about the density, then density is explained as mass by volume, right? Means how much mass is present in a particular volume. Okay, so you can say that the density is directly proportional to the mass. Okay, so if you compare the mass of these four different organic compounds, so what you can expect, as you can see that more the groups, more will be the mass, right? The bromine, chlorine, okay, in the option number D, if you see, these are the two different groups. Chlorine is common, one chlorine, here is chlorine, here is chlorine, and here is chlorine, right? But in option D, we have the bromine as well. Okay, and this bromine, you can say this is a bulky group. Okay, bulky, or you can say it's a big large group. Okay, it's a large group. Okay, so in the first option, you can see there is a simply a benzene. Okay, so definitely its mass will be less. Okay, because in all these four options benzene is common. Okay, so the first one should be least. Okay, so the density of the A should be least. So we have the which option, here we have the density least, and here option A is least. Okay, so option C and D cannot be your choices. Okay, so we have the option A and B. Okay, in the first and second option there is a answer. Now if you see the from A, B, C, D, D is having the two large groups, so that's why D should be the higher in mass. Okay, so D should be higher in mass. Okay, its mass should be highest. Now then we will have the C, because we have the 2 chlorine. Okay, so mass will be C, and then we will have the D. So option first is the very correct answer. Okay, answer number first, that is the A is less than B, B is less than C, and C is less than D, right? So mass of the D will be the highest. Okay, so this is the first question based on the density. Now let's move to the next question, question number 2. Arrange the following compounds in increasing order of their boiling points. Okay, so we need to compare the boiling points, right? We need to compare the boiling points. So what we understand by the boiling point? Listen, whenever we are talking about the boiling point, it means that uh, the breakage of the bond. Okay, right? Breakage or breaking of bonds, right? Breaking of chemical bonds. So bonds will break, then you will achieve the boiling point. Okay, so in these three options, you need to check that in which case the bond breakage is easily favorable. Okay, so if you see the first option, here we have this bromine halogen, right? So, and these three methyl groups are like this, and in the second option we have this bromine, okay, and this is the normal compound, okay, straight chain compound. It's a straight chain compound, right? Linear compound, you can say. It's a linear. And now here in the option number C, you can see that how these all the methyl groups are branched. So easily you can see that in the case of the C, we have more branching, okay. So more branching means the boiling points you will get easily, okay, because these groups are, you know these groups will easily dissociate, or you can say these bonds will easily get break, okay. So that's why the option C is C, okay. The boiling point of the C should be what? It will easily boiling point, in case of the B, this is the straight, so it is very very difficult. So in case of the B, boiling point should be higher, as you can just a minute, let me see. Yeah, in case of the B, the boiling point will be higher, okay, because this is the normal straight chain compound, and bond breakage will be not easily breakage is there. So option B, okay. So in case of the B, boiling point should be highest, and in case of the C, boiling point should be the lower, least, okay, and in case of B it is. So option third will be there, okay. Why? Because in case of the B, we have the straight chain compound, okay. In case of the A, we have the two different groups, methyl, two methyl are branched, and in case of C, all the four different groups are highly branched, okay. So that's why CAB is the perfect choice. Let's see the question number third. Which of the following is halogen exchange reaction? Now what we mean by the halogen exchange reaction? Halogen exchange reaction means the halogen will get exchanged, okay. So in case of the first, as you can see, this is the alkyl halide, okay, and this is the sodium iodide, okay. So when the reaction will look like, okay, how the things will go on, this will react with the iodide, okay, and it will form the Ri, and the sodium plus and halide, this will be NaX, okay. So this is your alkyl halide, this is your alkyl iodide, okay. So in this particular case, what you can see, is there any halogen exchange reaction? Yeah, you can say that the halogen is exchanging. In both the cases, this is the halogen and here is also the halogen, okay. So both the halogens are now exchanged, so option A should be our answer, okay. But let's check the second option. In the second case, this is the hydrogen halide, okay. So this is your X negative. So now this is simply the reaction is, you can easily expect that this will attack onto this carbon and this double bond get break, okay, and this unsaturated, okay, unsaturated compound will now become the saturated one, okay, with the halogen X, right. So this is your saturated, okay. So here you can say this is the addition kind of the reaction is there, okay, addition kind of the reaction, or yes, where the simply the reduction kind, the breakage of the bond, right. So it's not the halogen exchange reaction. Now if you see the third one, here we have this alcohol and this is the halide, okay. So what kind of the reaction is there? Rx formation has been taken place and the water is eliminated, right. So this is the alkyl halide formation is there, okay. So here we alkyl, here there is a substitution reaction, okay. You can say that there is a substitution reaction, okay, substitution reaction, because the halide is substituting, okay. And in the last case, you can see that what kind of the reaction. This reaction is occurring in the presence of iron and dark. Okay, so what kind of the reaction this is, so we will discuss this in the next question. Okay, so this is not the, it's not a halogen exchange reaction. Okay, it's a different reaction. It's not a halogen exchange reaction. Okay, now let's see the next question where we will discuss this reaction. Okay, let's see. Toluene reacts with the halogen in presence of the iron 3 chloride, giving the ortho and para halo compounds. This reaction is, okay, so in the earlier case, you can see this is your toluene. Okay, and it is reacting with the halogen in presence of iron, and the reaction is in the dark medium. Okay, in the dark. So here you can see this is your ortho product, ortho-allotoluene, and this is a para-allotoluene, right? So in these two cases, we have the ortho and para product. Okay, so which one is the suitable answer for this reaction? It should be the electrophilic elimination reaction, not look like this, because we don't have the, you know, electrophilic elimination reaction, electrophilic substitution reaction, electrophilic addition reaction, and nucleophilic substitution reaction. Okay, so in these cases, the reaction is not the nucleophilic substitution reaction, it is not there. Okay, and option C, I have written the wrong option in here. Option C should be the free radical. Okay, this option is the free radical addition reaction. Okay, free radical addition reaction. So if you see that this there is no free radical formation is going on. Okay, so this can't be your answer, right? Electrophilic elimination reaction or the electrophilic substitution reaction. Okay, substitution reaction is a possibility, you can say. Okay, and definitely it should be there. Okay, because in the electrophilic substitution reaction, addition and elimination. Okay, addition and followed by elimination. Okay, addition then elimination. Okay, this kind of the thing is present in the substitution reaction. So these are the this is the this reaction is the example of the electrophilic substitution reaction. All right, so I hope you got some good insights about this these problems. Thanks for listening.